Okay, next video then, still on the topic of algebraic long division within that chapter, we're now going to talk about the factor theorem and the remainder theorem, which is essentially quite nice because they are effectively the same idea. So, if we deal with factor theorem first, so that's going to be our next subtitle. Just move this up out of the way. So we're going to do factor theorem. Okay. Essentially, I'm going to give you the waffle that comes from it. So basically, if your function of x say if you've got a function of x and then you plug in some value, which we're going to call p. So you plug into that function of x some value p. If that comes out with an answer of 0, then you can know for certain that x minus p is a factor. Right, let's see what that actually means. So we've got some function of x. That was our starting point if we've got a function of x. So let's just show you a real example of this in action. So let's start with our function of x, and we'll use for this our function of x as being equal to x cubed plus x squared minus 4x minus 4. Okay, now you might get a question that would say something like, show that x minus 2 is a factor. Okay, so if we go back to what our original statement was, if some function of that, this is a value p, then this would be a factor. So the only thing to notice, we have x minus p here. It's the value of p that makes this bracket 0, a bit like solving when we solve a quadratic. So it's kind of the negative of. So if we had x minus p, we'd put in p into the function. So in this tangible example, we've got minus 2, x minus 2, that's our p value. So what we're going to do is we're going to put in to our function of x f of, instead of minus 2 obviously, now it's going to be 2. Now, if we get an answer of 0 coming out, then we can say that x minus 2 is a factor. So we're looking for this to equal 0. So let's go through it. What have we got? We've got x to the 3, so in this case it's 2 to the 3, plus 2 squared, minus 4 lots of 2, take away 4. So we're looking for this to equal 0. Let's have a look what we've got. We've got 2 to the 3, 2 for 8, plus 4, minus 4 times 2 is 8, minus 4, 12 minus 12, which equals 0. So, because we've got the result of f of 2 equaling 0, let's just copy this down, f of 2 equals 0, we can say for certain then, therefore, x minus 2 is a factor. And that's all there is to it, really. So, if you're asked to show something as a factor, find the value of x that makes this bracket 0, so in this case it would be 2. You plug that into your function, and if it does equal 0, then it is going to be a factor. And you can show this, we could show this by dividing this by then x minus 2, which is something you'll often be asked to do. So essentially, before you start your division, you'd quite like to see that it's going to work, so you'd plug in 2, see that it will work, and then you can do your algebraic long division on this by dividing this whole thing by x minus 2, and it will start that factorising process. So that really is our factor theorem. Okay, Moving on then, we need to also do the remainder theorem, which, as I said, is a very similar sort of thing. So, what have we got? Our remainder theorem. Okay, as I said, exactly the same. Oh, time for a lesson. Okay, let's just finish off where I was. Remainder theorem, exactly the same process. So you're going to plug in a value into your function of x. Okay, so let's go through the waffly algebraic explanation first. Okay, so you can find the remainder. So the remainder, essentially remainder, remember, is just what's left over when we divide through by something it doesn't fit exactly. Okay, so the remainder, didn't mean the, I'm going to say when, the remainder when your function of x is divided by let's put two figures in here, ax minus b is your function of b over a. Exactly the same idea. I'm looking for this value, which is what makes this bracket 0. That's b minus a. If you think about this, if we set this equal to 0, we'd add b, then we divide through by a. So it would be the function of b over a. So the remainder of the function x is divided by ax minus b is the function of b over a. Okay, so let's just do a quick example, and then I'll show you a type of question you might be asked. So a quick example, let's find the remainder when 4x to the 4 minus 4x squared plus 8x minus 1 is divided by, just run out of space, is divided by 2x minus 1. Okay, so that's essentially what we're going to do. Find the remainder when 4x to the 4 minus 4x squared plus 8x minus 1 is divided by, not very good, not very neat this one, it's gone down, 2x minus 1. So essentially the first thing we're going to do is we're going to look at this 2x minus 1 that I've got here that I'm going to divide it by. To find that remainder I need to find what value of x will make this 0. So if I want to do it the long way, I can say 2x minus 1 is equal to 0, 2x equals 1, so x equals a half. That's what I'm going to sub into my function of x. So let's move this back over here. So my function of x is this, so I want to know what the function is when I chuck in a half. So that's going to be 4 lots of a half to the 4 minus 4 lots of a half squared plus 8 lots of a half minus 1. So what does this become? Let's think this through. First of all, half to the 4, so I'm going to 2 to the 4, 2, 4, 8, 16, so it's 4 over 16. Again, remember to do the index first, half squared, so it's 4 over 4, effectively. Plus 8 lots of a half is just basically 8 over 2 minus 1. Let's do this one step at a time. So we've got 4 over 16 is a quarter, take away 1, plus 4, take away 1. So what does that become? I can do a quarter, I'll do that at the end, plus 2. And so that equals, obviously, 2 and a quarter. So that then is the remainder when we divide, remember that was the original question, divide this function 4x to the 4 minus 4x squared plus 8x minus 1 by this 2x minus 1. Okay, just to finish off this video then, I'm going to just talk through the type of question you might get in order to apply this remainder theorem when you're going to have to use some of your algebra. So I'm going to go change my ink to black, and the question is going to be something like this. You've got a function of x, f of x. You can write that this is an e.g. at the top. F of x is equal to x squared plus 3x plus q. X squared plus 3x plus q. And it says, given that your f of 2 is equal to 3, you need to find the f of minus 2. Okay, so we're going to go through the process, and essentially we're using the remainder theorem. We're going to plug in numbers into our function. So our function of x has this unknown q in it. We're going to have to find this first, and then we're going to have to chuck in minus 2 to our function instead. So first move then, let's put f of 2, which is going to be obviously 2 squared plus 3 lots of 2 plus q, and we know what it equals, what it comes out with, because it's in this given that, and it should give us an answer of 3. So that equals 3. So let's work this out. We've got 8 plus 6 plus q equals 3. Plus q equals 3, and so q equals 3, minus that 14, so q is minus 11. So let's just write out my function of x in full. What have we got? We've got our f of x. Oh, so it's just gone off the page. So I've got it written down here. So my function of x is x squared, x squared plus 3x. It was plus q, but no q is now worth minus 11. And so I need to now find, if I look back at the question, what the f of minus 2 is. So I'm going to just chuck that in to finish this off. So f of minus 2 obviously equals minus 2 squared plus 3 lots of minus 2 minus 11. Ooh. So minus 2 squared is 4 plus 3 lots of minus 2 minus 6 minus 11, which is 4 minus 6. You're in the video, Mrs. Byron.
Oh, sorry.
That's okay. 4 minus 6 minus 11.
I'll do a song.
Of course you can. Minus 2 minus 11, which is minus 13. And that's the answer that we're looking for at the end of this question. And unless Mrs. Byron does a song, we are finished. I think she's got a bit camera shy. Okay, that's us done.